Hi, welcome to the third session on continuous arguments. As we indicated in the last session, we are going to define logarithmic function on C star, the non-zero complex numbers. Again, this is going to be so-called multivalued function, and we are going to prove a very important result. If U is an open subset of C star, then continuous logarithm exists if only if continuous arguments exist. Therefore, what is the corollary? We cannot define continuous logarithm on C star. Okay, then we will go to define the so-called power function, like in real analysis x power alpha we define, right, where x is a positive number, alpha is a real number, x power alpha we define in such a way that when alpha becomes a natural number, okay, our definition of x power alpha coincides with x power n, that is x times x times x n times. Okay, all these things we would like to imitate in the context of complex numbers. Okay, let's get started. Yeah, so let us recall, if the exponential function from r to r is such that exponential of x r is completely r plus, that is all positive reals. This is we know, right? And we also know exponential is okay, strictly increasing, and limit extends infinity of exponential of x is infinity. Okay, and of course exponential of 0 is 1, and so on, and exponential of x equal to 1 by e power x. All these things we already know. So the important thing what I want to say is, therefore exponential from r to r plus is a continuous bijection, and its increasing function, therefore its inverse, okay, exponential inverse, that inverse of this will be r plus to r, will also be continuous. Is continuous bijection, and it will also be increasing. This inverse is what we denote by log. That is, what does it mean? Log of exponential of x equal to x for all x in r, and for all alpha in r plus, okay, exponential of log of alpha will be alpha. Okay, that's what we mean by inverses of each other. Okay, okay, just recall this, make sure that all these things you understand, because most often students do not learn about these things except in calculus. They know how to work with exponential derivative, logarithm derivative, integrals, etc., etc. Okay, but that they are inverse of each other and their properties should be understood well. Okay, so let me just make a pause, review, proceed. Okay, now we also know when it comes to complex numbers, I know this is continuous and onto, not a bijection. It's not a bijection, not 1 1. Why? Because we know x power z is same as x power z plus 2 pi I, or 2 pi I n for every n integer. Therefore it's not 1 1, right? Therefore there is nothing like define logarithm to be the inverse of exponential function. So let us go. So I said z in C is a logarithm of alpha in C star if exponential of z is alpha, right? Right. Now how to find, okay, does, first question is, does logarithm of alpha exist? That means whether there exists a complex number. Let us look at that. Alpha we know is mod alpha e power it, or let me write exponential it. Is that okay? Right. Now remember what I am looking for. I am looking for as z such that u exponential of z must be this. Right? Let's work backwards. Now suppose z is one side, then let us write z as x plus iy and such that exponential of z. I am working backwards. Suppose this holds. That means exponential of x plus iy must be equal to alpha. But this fellow is exponential of x into exponential of iy. That must be equal to alpha. You understand that? Yeah. But this tells me, therefore, what is mod alpha? Mod alpha is modulus of exponential of x into modulus of exponential of iy. Remember, y is a real number, therefore it's exponential of x, because exponential of x is also positive, right? And this is by standard calculus notation e power x, if you are uncomfortable with that. Therefore x is nothing other than log of, or let us say ln of mod alpha, where ln is the inverse of this, where exponential is the continuous bijection of r onto r plus. Okay, I am using ln so that it does not interfere with the log. Okay, this ln is a American notation. It stands for I do not know, natural logarithm or Naperian logarithm. Okay, therefore, so what do you think we have found? If at all a logarithm of alpha exists, call it z, then its real part is nothing other than the natural logarithm of mod alpha. Good. So now let's go back to right then. Therefore, what I have done is alpha is exponential of x into exponential of iy, but this is nothing other than mod alpha into exponential of iy. Right? Therefore, what is y then? This implies y must is an argument of alpha. Do you recall that? Yeah. So we have found what is thing I have found? This we have found if and only if. What we have found is z in C is a logarithm of alpha in C star if and only if I write x equal to x plus iy, let me write if and only if x is natural logarithm of mod alpha and y is an argument. Okay, because if this x and y, you can see x plus iy is exponential of x into exponential of iy, but exponential of x is exponential of natural logarithm of mod alpha into exponential of iy, but this is mod alpha and this is exponential iy, but that's an argument. Okay, and since y is an argument, this is alpha. So pause, review, proceed. So what have I shown? I have shown that if alpha is a non-zero complex number and if z is a logarithm of alpha, that is exponential of z equal to alpha, if I write z equal to x plus iy, x and y cannot be arbitrary. X must necessarily be logarithm of mod alpha. Right? Next, what should be y? Y must be an argument of alpha. Therefore, what does it say? So for every non-zero complex number alpha, logarithm can be defined. Namely, take x equal to logarithm of mod alpha plus I times y, where y is an argument of alpha. Right? Make sure that you understand this. And now where does the multivaluedness of a logarithm comes? Because the argument is not unique. Okay, natural logarithm of mod alpha is unique. There is no problem with that. You follow that? So, and again notice that we are using the property our exponential function should be exponential x plus iy should be equal to x plus exponential of x into exponential of y. That property is needed. Okay, therefore exponential x plus iy must be equal to mod exponential of x into exponential iy, but that should be equal to mod alpha into, okay, e power exponential of I times its argument, etc. Okay, if I keep repeating you will only get confused, so let's go along with that. So the next thing I want to know is the following theorem. So the question is whether there exists a continuous logarithm on u in c star. Okay, right. Suppose, what do I mean by that? Lambda is a function from u to c, so that for every z in u, exponential of lambda z will be z. Yeah, then lambda is a logarithm of, then I'll call lambda of z a logarithm z. So what do I want? This map z going to lambda z must be continuous, right? But just now we saw something very interesting. Okay, any logarithm must be got this lambda of z must also be ln of mod z plus some I times some theta of z, where theta of z is an argument. Right? Yeah, because we also saw this must always be an argument. Now something very interesting. Suppose lambda is continuous logarithm, right? Then I theta of z is lambda of z minus ln of mod z. Okay, and this is continuous, and z going to mod z. Okay, this is from c star to r plus to r. This is a logarithm. Okay, these are all continuous functions, therefore this is continuous, therefore it implies theta is continuous. That is, if a continuous logarithm exists, then continuous argument exists. Now converse, suppose theta is continuous, right? Then I can define a continuous logarithm. How will I define continuous logarithm? By the same object. Define lambda z to be mod z plus I theta of z. Okay, now this is continuous, therefore this becomes continuous. And exponential of lambda z is exponential of ln of mod z plus exponential of I theta of z, but this is mod z into exponential of I theta of z. But remember, theta is continuous argument, this is mod z, therefore this is equal to z. So I got it. Okay, so what do you think I have proved? I have proved a result. So this is the theorem which I have proved. Let u in c star be open. Okay, then a continuous logarithm exists on u, continuous logarithm lambda. Okay, that is for all z in u, exponential of lambda z is z. If and only if there exists a continuous argument on u. That is, for every z in u, continuous argument theta on u. That is, for every z in u, okay, z is mod z and exponential of I theta of z. Okay, this is all we have proved. Make sure you understood this. These are the things which you will never learn properly. Right? Once you are done, we can next ask the next question. Okay. Therefore, what is the obvious conclusion? There exists no continuous logarithm on C star. Because if a continuous logarithm exists, that will mean continuous argument exists on C star, but we know it does not exist. Now, do you see that? All the trouble for of so-called multi-valued maps is because of arguments. So there is no argument about that, right? A pun. Okay. So without any argument, argument is the source of all the multivaluedness. Okay. You will find. Okay. Many people think it's logarithm. Logarithm is not the culprit. Real culprit is argument. Okay. Keep that in mind. We'll do that. So what is the next question I can ask? Therefore, let's look at our U alpha. Do you remember U alpha? For alpha in R, we define U alpha, which is a subset of C star. Okay. Equal to Z in C star. So that Z by mod Z is not equal to e power I alpha. That means I just to take away this line thrown out. So this is usually one calls slit plane. But you slit it across one ray. Okay. So we know on this there exists a continuous argument. There exists U alpha to R a continuous argument. Okay, it actually takes in values in alpha to alpha plus 2 pi. Right? That for every Z in U alpha, Z equal to mod Z into e power or exponential I theta alpha of Z. All these things we have shown. Therefore, continuous logarithm exists on U alpha. Why? I define lambda alpha of Z equal to natural logarithm of mod Z plus I theta alpha of Z. Okay. But the interesting fact, I will make it a separate video. Interesting fact is any continuous logarithm on an open set is in fact differentiable on or holomorphic or analytic. I don't know which way you know on U. This is a very interesting fact. Just continuity. Okay. If I have a logarithm on an open set and if I know it is continuous, then remember that's going to be a function. Remember that will be a function from U to C now. Okay. Suppose call this a logarithm as lambda. Why did I call logarithm lambda? You see that L appears. That is why I call it lambda. Maybe one can also denote by capital lambda. Okay. This is a fact. There is a direct proof. But in my book I have given a proof maybe I had given a proof elsewhere. But the proof which I remember is after inverse function theorem for holomorphic functions. But there is a direct proof. I am not sure whether I have given it in my book, but I will give it in one of the lectures here later. Okay. Right. Now let's ask the next question. Since we already know, suppose lambda and lambda prime are continuous logarithms on a connected open set. Right? Then we know that my lambda must be lambda alpha for some alpha. Otherwise, lambda prime is lambda plus 2n pi I times 2n pi. for any integer n. You know how to do that? Yeah, because exponential of z equal to mod z into exponential of I, okay, theta of z, and that's all equal to mod z exponential of I theta dash z. Remember, whenever lambda is a continuous logarithm, it immediately gives me continuous argument. How do I define? Because lambda z equal to ln of mod z plus some I theta of z. Therefore, theta of z is defined to be L of z minus ln of mod z divided by I. Okay, and theta dash is also defined like that. Do you understand that? Now, therefore, I theta of z and theta dash of z are arguments of z. Therefore, they differ by a constant. Therefore, theta of z minus theta dash z equal to some 2n pi. This n may depend upon z, right? Therefore, let's look at the map. Z going to theta of z minus theta dash of z by 2 pi. Okay, this takes values in z, and this is a continuous map, okay, on a connected set u. Therefore, this map, if you call it as a f of u is contained in z. Okay, and the only, this is a subset of real numbers. The only connected subset of real numbers must be, you know what it is, it must be interval, degenerate or non-degenerate. Therefore, this f of u must be a constant, some integer n. That's it. Okay, this is exactly the same way we argued for argument. So please go through, understand. Okay, therefore any argument on u alpha is of the form lambda alpha plus I times 2n pi. Not any argument, I am sorry, any continuous logarithm. Okay, so pause, review, proceed. Okay, right. So these are all called branches of logarithm. I do not use such words usually in my book also. It is called a branch of a logarithm. So lambda alpha is a branch of the logarithm on u alpha, and lambda alpha plus I 2n pi is also a branch of a logarithm. A branch of the logarithm. Okay, right. Now let me go to the next one. This is what I wanted to do. Okay, right. Is there anything else I would like to say? Yes. Yeah. Now suppose, let us look at. Now suppose let's look at one in C star. Okay, right, or let us look at I in C star. Okay, now I look at u0. This line is missed. Okay, there is a positive real axis is thrown out. This is thrown out. The rest of things are all okay. Right. Okay. Now, what are all the possible logarithms of I? So you know that exponential of I pi by 2 is I. Right. Therefore, okay, logarithm of I is I pi by 2 plus, okay, any 2n pi I. Do you understand this? Okay. And suppose I look at, let's look at u pi by 2. That means I am just doing away with this line. The rest of things are there. These are all there. Right? Now 1 is there. It has 1. Right? Now we know exponential of 0 is 1. Right? Therefore, what are all the possible logarithms? Okay. 0 plus 2n pi I. We know all these things. That is 2n pi I. Just for make sure that I want you to understand carefully. It should not only be theory. You should be very comfortable with numbers and deal with that. I am going to use it also soon. Okay. Now we want to talk about powers. Remember, in real analysis, if x is positive, alpha is any real number, we define x power alpha. Again, many of you might have forgotten how x power alpha is defined. You know its derivative is x power alpha minus 1 by, right, by alpha, where alpha is not equal to whatever. Okay, 0, etc. Right? Okay. But what is the actual definition? This is the definition of e power alpha log x. That is exponential of alpha log x. Do you understand? This is the way we are defined. Then we know x power alpha is differentiable. Its derivative is, as I said, whatever it is. Okay. So this is a function. This is a function from R to R, x going to x power alpha. This is a differentiable function. If alpha is 0, it's a constant function. Therefore, it's differentiable. Otherwise, it's exponential alpha log x. We'll make sure that you know how to do that. Okay. Now, how to define z power alpha? If I want to mimic this definition, so z power alpha, I can define it to be, how will I define? Exponential of alpha into logarithm of z, where lambda is a logarithm. Lambda z is a logarithm of z. Right? Therefore, this is again a multivalued map. Because lambda itself, I do not know for given a z, non-zero thing, what is z? I think I said z is non-zero. Right? I know there exactly is one logarithm, but which logarithm I am going to take, it's not very clear. Do you follow that? This is our definition of z power alpha. So what I do is, again, as we did, suppose I have u alpha. Okay, then theta alpha and lambda alpha continuous logarithm exist. Continuous argument. This is continuous logarithm. These are all continuous. It exists. Therefore, I can define z power. Oh, I used alpha here. It's a pity, right? I'm using the same alpha here. Do you see that? Yeah. Let us simply say, okay, this lambda also I used. So I'm running into problem in the sense that, okay, let us look at beta, gamma, mu. Okay, mu, u mu. Okay, where mu is a real number. Then theta mu, lambda mu are continuous arguments and logarithm respectively. Therefore, I can define z power alpha to be exponential of alpha, and what do you think I will define? Lambda mu of z, because z belongs to this, therefore continuous logarithm exists, therefore this. Therefore, now notice that, yeah, therefore the function, therefore the function z going to z power alpha from u a subset of c star or u mu to c is continuous. Yeah, and if you believed any continuous logarithm is holomorphic or differentiable or analytic, then you can see z going to lambda mu of z is analytic, multiplication by alpha constant is analytic, and composite of exponential function which is analytic, therefore the composite will also be differentiable. Okay, so you can see this is the way we have. So go back. So what do you think we have done? We have learned that continuous arguments, logarithm and powers are multivalued maps. Okay, then how do I tackle them? The way to tackle this, instead of asking for the entire domain to be C star, you are ready to consider a slit plane. That is, you remove one half ray starting from origin. On the connected open set, I can define continuous logarithm, continuous argument, continuous logarithm, and continuous actually differentiable logarithm and differentiable power functions. Okay, this is the way modern mathematics learn how to deal with that. Okay, you will see later whenever we look at in something later when you do residue calculus etc. we may have to deal with this kind of multi-valued maps. Then how do we deal with it? We will use this kind of idea there. So that is the way to circumvent multiple. So instead of being kind of confused or intimidated by multi-valued maps, modern mathematics has learned a way how to grapple, how to work with it. Okay, that's what you also should learn. So I would like to finish the lecture with a few more points. Yeah. Now let's look at I is a complex number. Let us look at I power I. Okay. Therefore, this I, where does it live? It lives in u0. Okay. This line is deleted. Okay, good. Now, what is this definition then? This is exponential of I times. Okay, what is this? I have to say lambda 0 of I. Okay, lambda 0, that for lambda 0 I would define what is theta 0. Theta 0 u0 to 0, where does it go? 0 to 2 pi. Right? Therefore, what is theta 0 of I? That is pi by 2. Are you following? Therefore, what is lambda of lambda 0 of I? That is natural logarithm of mod I plus I theta I. Theta 0 of I. Do not get confused by the notation. That is why concepts are important. If you understand the concept, this kind of too much of suffix, superfix, too much of notation should not bother you. Theta 0 is a continuous argument on C star where the positive x-axis is removed. Therefore, the angles will be 0 to 2 pi. And lambda 0 is the continuous logarithm on this set. We know how to define. This is a logarithm of 1, natural logarithm of 1 plus I theta I 0 is pi by 2. Therefore, pi by 2. Right? Therefore, lambda I, we have found out it is I, nothing other than I into I pi by 2. This is exponential of minus pi by 2. Do you understand? So, isn't it amazing? I have a pure number, purely minor number, raised to the purely minor number, and okay, its value, one of the values is e power minus pi by 2. Okay, what are all other possible powers? We see that. So all possible powers are also exponential of I, okay, right, into whatever possible. What are the possible logarithms? any lambda of I should be I pi by 2 plus 2n pi I, right? Therefore I can take I out. Therefore it's I into pi by 2 plus 2n pi. Therefore it's going to be e power minus pi by 2 into e power 2n pi. Okay, so I power I must belong to this set as n is over z. You see that all the power I power I are all real numbers. Isn't it amazing? Okay, next let us look at, suppose I have z in C star and n is a natural number. Okay, sorry, n is a natural number, z also is similarly. Now z power n has two meanings now. Z power n is z times z times z n times, or it also has the meaning exponential of n some lambda z. You understand that? Where lambda z is some logarithm, a logarithm. I don't know which logarithm, let's not worry about it, because I do not know z is going to be in which u use what do you call u alpha, the slit plane. Okay, some logarithm, right? Okay, now what is this? So but we know anything is of the form logarithm of mod z into I, okay, theta of z, where theta of z is some argument, an argument of z. Is it okay? Right? Therefore that plus, if you want, plus 2n pi. Are you following? Sure? Okay. So let us fix one. Okay, let us say it, where fix at t. The other one will be ln of mod z plus I t plus 2n pi. Right? Therefore, what is z power n according to our definition? It's exponential of n into log mod n plus I times t plus 2n pi. Okay, right? This is exponential. I will not again, this you can see this is nothing other than exponential of n times ln mod z plus exponential of I times t plus 2n pi. Yeah, but this is going to be mod z power n, yeah, into, there is also an n, I forgot this is n times the whole thing, I am sorry, I was just wondering, n times the whole thing. Okay, into e power int, but remember it is mod z e power it power n, and also times e power, there is an n, therefore this will be some k. Some k is an integer. Okay, any argument will differ e power I n k t 2 pi, but that's going to be 1. Therefore, but this is z power n. Do you understand what I am doing? What I have shown, please go through. What I have shown is for z power n there are two definitions. One is z times z n times, the other one is exponential of n lambda z, where lambda z is some logarithm of z. But what I am saying is, it does not, this logarithm may be multivalued etc., but I don't care, take any logarithm of z and this fellow will turn out to be z power n. Okay, therefore our what I have shown is we had extended the power, right? That is, even in real analysis, this is the problem. You have x power n where x is positive. X power n is x times x times x. But this is also a definition of e power n log x. E power n log x is e power log x plus log x n times. Therefore, it's e power log x into e power log x. This is x into n times. Therefore, x power. Do you understand? Most often you may not have even seen these things. Okay, teachers don't take enough care to explain these things. So yeah, when they define x power alpha, when alpha is a natural number, we already have another definition x power n. Do they coincide? Even in real analysis, they coincide. It's easy. But here, in this case, it's also easy, but it's slightly more significant. Why? Because logarithm is multivalued map, so I do not know which logarithm I might have ended up with. Okay, my z may be in one of the slit domains, which I do not know which slit domain it's going to be. Therefore, there is one particular continuous choice I may use, but the same z may be in many slit domains also. Do you follow that? It will be in infinitely many slit domains. The same z in C star will be in infinitely many slit domains. Therefore, my z power may depend upon the slit domain also. But what we are showing is it does not matter. You take any any logarithm of z, the result is the same. Please understand, these are the things which are. Please go through this. I hope you will be very excited and slightly even intimidated or confused. But go through it. These are the things which people try to show, although it's a mystery, magic, and you may not be good enough to understand, etc. All of us can understand. It's very easy. Okay, try to go through. If necessary, watch it. As not if necessary, as I keep saying, watch this with your friends, discuss that, and rewind, play it again. You will be master. You will never ever be intimidated by these words: multivaluedness, etc., logarithm, square function, square root, nth root, etc. Also I can explain now, but I had already done that as a motivation for argument, so I don't want to repeat. Okay, please go through it. Okay, if you have some problem, please write in your comments. I will produce another video to answer those things. Okay, I hope you enjoyed. We will meet again.